Hi guys. Chapter 9, Field Manual 4-01.41, U.S. Army Railway Operations, Chapter 9, Wreck Crews and Equipment. Wreck crews operate equipment assigned to the wreck train. They assist the clearing of the wrecks and other line obstructions. Interruptions of the rail traffic. Interruptions of the rail traffic must be clearly mediated. Must be cleared immediately. Major interruptions are reported to the commander of the Transportation Railway Group and the brigade, so the adjustments may be made in the traffic flow. Interruptions may be listed according to the major causes. Interruptions may result in the following major derailments, minor derailments, washout, flood, slides, tunnel cave-ins, and guerrilla action. Since the Chief Dispatcher Transportation Railway Battalion Headquarters controls the movement of the trains and first office notified of the event of the traffic interruption, the Chief of Dispatcher immediately advised the Battalion Commander, Division Superintendent, the Battalion Executive Officer, Assistant Superintendent, any of the interruptions. In this absence, the Chief Dispatcher takes the direction and action required, such as ordering the wrecking crews. Major interruptions are reported promptly through the command channels, and assistance may be obtained by the engineering commander, the communications personnel, local civilians. In any case of the accident in the following a train, the conductor is charged with until the senior battalion officer arrives. The battalion represents the responsibility of restoring the services. He takes chains of coordinated with the work of the wreck crew master, track foreman, and other wreck personnel in the clearing of the line. This keeps the chief dispatcher informed of any of the work process. Rail units are responsible for restoring the rail traffic as quickly as possible. Assistance may be obtained by the engineer or in signal services command units when required. If the interruptions occur with a double track, line track is restored immediately to the one track. The other line is cleared later. The following is some major causes of the rail traffic interruptions: enemy action, including aerial bombings, artillery, rail fire using the conventional and nuclear weapons, and guerrilla activity, human failure, including improper train operating, violation of the rules, improper inspection, maintenance of the equipment of the facility, failure due to the equipment facility faults or defects, natural causes, including flood slides, washouts, lightning, fires, and so forth. Major interruptions. The cause of the major interruptions of the rail traffic and theater operations are mechanically human failure, natural causes, enemy action, and corrective action must be taken and be decisive and prompt as conditions are permitted. When the traffic is disrupted, the paramount objective is to reopen the line as quickly as possible. Major derailments and wrecks. Clearing the operation is established by both sides. Derailing if the wreck or the equipment is available to save the pending arrival of the wreck trains. Undamaged if the car showed, but be pulled in from the site and parked on the first available side of the spur. Damaged cars should be rolled off to the right of the way to pick up the later. Traffic should be rerouted when the length of the interruption justifies, and if an alternate line is available, the rail track transfer point may be established if required. Washouts. 9.4. Floodwaters may be carrying away bridges, trestles, and culverts. They must all enter the section of the right way and the roadbed. Restoration may require the temporary structure of the field expeditions. Action to be taken out of the washout are likely to occur with be planned, and the repair materials should be stockpiled at suitable locations. As in many interruptions, urgent traffic should be diverted and rerouted, and alternate lines exist. Personnel may be transferred from one train to another, walking and around the washout. The transfer points established in the mode of transportation. Suitable roads are available. Floods. Floodwaters may cause most damage to the railway plants and equipment. They can cause the following to happen: bridge trestles and culverts to be weakened and destroyed, grade ballast and subballast to be washed off, equipment to be floated away, and contents of the load to be damaged. Damaged track, roadbed, or structures may take several days or weeks to repair, which may cause the operations to become standstill, mud, silt, and left behind by the receding waters interfere with the operation. Switching electronic signal mechanisms, rail lines, which with the course of the river to avoid the steep grades frequently incur with a series of damage to the flood rivers. The little can be done by the protecting against the floods, except for the taking of certain protective measures. Bearing the flash of the floods from the cloud burst, rail personnel will often advise the warning of the rising waters which may be expected to develop in flood conditions. The train dispatcher records weather conditions on his train sheet every 6 hours for the most of the station on his division. These reports may offer the first indications of the impending of the high water. Local weather bureaus, local labor forces for the valuable opinions of how and high a crest may be expected. Protective measures. 9.6. Critical freight and equipment branches beyond the threatened area loaded at cars and other equipment should be moved to the higher ground. A storage industry that has a higher than the yard and main tracks, even though the running up and down up to the down of the hump is showed by the field with the loaded cars on the most vulnerable water damage. The moving ammunition, explosive clothing, and the foodstuffs. The higher ground logically precedes that the field pieces, vehicles, and other freight must not be particularly vulnerable to high water damages. Detailed standard operating procedure sites preceding the freight water to be moved, and the safety. This is often there are often any of the branches that run to the right angle, threatening a river that may provide excellent storage places for vulnerable freight and equipment. If possible, all locomotives should be moved to the higher ground. Diesel, electric, and electric locomotives should be moved from before steam locomotives. Rail bridges and often flooded rivers may be weakened and washed away. Bridges may appear timber pile trestles and are often vulnerable because of this pressure collaborated with the debris. The weight of the heavy loaded cars in such structures usually tend to stabilize and assist anchoring, bridging, and trestling. Such cars should be on only a few low-grade aggregates such as coal, ore, gravel, and so on. However, the method should not be used without approval of the engineered bridge specialist or other qualified engineer personnel. Cave-ins and side-ins. Alright, the following, particularly in every mountainous area, are often major causes of rail traffic interruptions. Tunnels and cut cave-ins, dirt slides, rock slides, and snow slides. These may result in nature causes such as earthquakes, melting snow, soaking rains, and form the enemy actions such as bombing, ulteriorly sabotage. Cutting slides are cleared in the most expeditious manner possible without regarding permanently construction. Heavy equipment should be requested in engineer service task on when clearing the obstruction is beyond the rail. The transportation operations capability when possible collapse tunnels should excavated or daylight is to create a cut into the place if not feasible to have a bypass shoe fly track may be constructed. A terminal yard and terminal congestion is often protected by the major traffic interruption. Poor control of the movement to maintain fluidity. Yard terminals should be not filled with about 60% of the static capacity. The yard to enforce a yard is often blocked or has been short. Should report the situation to the chief dispatcher. The yard may request that the cars be off at the sidings of the diverted off the other lines or yards may normal terrain movement and is resumed. The battalion commander division superintendent may request the Transcom transportation officer to imply embargo or rail movement if the situation becomes serious. Minor interruptions. Although many factors might cause minor interruptions, they're generally classified in one of the three common categories. Each of these categories is discussed as follows. Derailments 11. Minor derailments are most often caused by the equipment's failure, such as dragging, backing, rigging, sharpening, wheel flanges, splitting switches, wheels overriding, derail, so forth, and derailments usually repaired quickly by train crews using the re-railing devices jacks carried on locomotives. As more of the serious derailment may require the train brought by the re-rail of the cars and repair the track damage. Minor floods and slides and washout. Local track gangs normally repair the minor flooding, slidings, washout tracks, and drainage culverts, rock, mud, and snow slides removed from local labor maintenance of the way equipment without need of the work state and train and necessary repairs. Materials should be stockpiled at a suitable location as division right of the way where their interruptions are frequent. Signal communication to interruptions. The local signal section personnel can usually quickly repair a minor break in the dispatcher circuits as is instructed by the chief dispatcher. Local block operations may continue with the movement of the trains and the fleet operations during such break, and such single service assistance may be requested in making signal communications line repairs which may be beyond the scope of the railway personnel. Wreck trains. The Transportation Railway Company, TOE 55917, provides a wreck train support division. The wreck train consists of locomotive, wreck train, tool cars, enough for the bunk of the cars and for the personnel required for the particular wreck. The wreck cranes and tool cranes are stationed in particular points along with the railway line. Division terminals are considered strategic points because of the locomotives and engine train. Wreck crew cars are available on call. Wreck train equipment must be prepared for the immediate movement of the ties, rails, spikes, and other part materials stockpiled in various points. The emergency supply of each such item is also located in suitable cars held in the wrecker. As part of the wreck train, the transportation operating company furnishes the locomotive to the train crews of the wreck crews. Wreck trains may be obtained by the host nation's resources. Traffic interruption. The derailment of Wreck Brock's mainline traffic dispatcher secures a complete track record as possible extent of the damage. He also estimates the time required of restoring the train movement. The dispatcher orders and arranges the wreck train. Its crews immediately to scene. The serious wrecks of the wreck train may be ordered to the out of the division points at the both sides of the work of the hash and the clear operation. The dispatcher also notifies the following to take appropriate action in the area of responsibility: superintendent, train master, train masters and train crews, unit commander, train master, mechanic, wreck crews, wreck car crews, maintenance of the way, superintendent, track repairs. These officers are seeing the accident as the fastest available means of surviving the situation must play ends of the wreck crane is making immediately upon its arrival. The prime objective is to go to the line as quickly as possible. Cleanup and salvage operation can be performed as later as necessary. The wreck crew cars. Wreck car crews. The wreck crew operates the general supervision of platoon leader from the railway equipment and maintenance platoon. The wreck crew consists of the following: wreck foreman and NCOIC crane operator, car repairman, welders as required. The crew operates the equipment as assigned to the wreck train. An officer is a senior NCO designated by the wreck master of the commander company or is the wreck master by a company commander is in charge by the wreck crews. 917. The mission of the crews is remove wrecks and other obstruction. They also salvage the wreck. They also salvage and repair wreck rolling stock so that it is safely moved to the nearest shipping and repair track. The wreck crews coordinates closely with the maintenance of the way platoon personnel are sent to the scene. The mission is the platoon is to repair, restore the right of way of the tracks damaged and destroyed by the derailments, acts of God, and sabotage, and so forth. The wreck crane operators. Crane operator must know the parts of the principal operation safety precautions required by the crane when assigned. He must be familiar with the types and capabilities of cable, rope, wire ropes, blocks, hooks, and shackles with the crane is equipped. An operator must supervise the rigging of the crane, and in particular lift, the most understanding the mechanical advantage of the various pulley combinations used with dead man riggings and other expedition required for the re-railing locomotives and cars. Safety. 919. To general rules of the field manual 5521, which relate to safety to be first important as the discharge of the duty. Obedience of the rules essential to the safety. Operating rules. 920. Personnel engaged in the operating wreck trains, cranes must familiar with the railway safety operating rules given in the field manual 5521. All personnel whose duties affected by the rules of the publication must be provided with the wreck crane. Crane personnel must ensure that the cables of the tactical adequate strength are used in making the heavy lifts. All personnel are warned to stay away from any of the where there is possibility of being injured if the cable should break and load and slip. Pre-operational safety checks by experience have improved the normal potential hazards inherent. The wreck crane operation safety checks are performed by the crane operation safety practices incidental operating the crew making heavy lifts and are discussed in the following paragraphs. Equipment servicing: engine, fuel, lubricants, water checks on the brew out through the proper levels, open the gears, fitting of the grease, and the power of the stoppages of mechanical failures caused by inadequate servicing that can cause the damage and injury. Wreck cranes should have the air brake, hand brakes, and generators, electricity, lights, and crane should be capable of self-propulsion if in their either direction. The deck platforms. Wreck crane deck. The platforms must keep the grease, cable, chains, buckets, barrels, loose tools, and similar items free. Machine guards and over the open gears should be in place. Handholds and the steps may be kept clean and secure and marked on as appropriate. Brakes and clutches and switches. Action affecting all the braking devices, clutchings, and the engine cutoff should be checked and required if the adjustment is made. And assuming that his position, the crane operator will test in the condition of the controls of his ability to operate quickly, automatically in an emergency. Crane operators must ensure all dogs, paws, and braking equipment are capable of effectively braking the weight of at least one and 1/4 times the weight of the full rated load. Outriggers are usually the testing crane rated capacity, but the rated capacity of the crane should be that given without the outriggers. Cables. 925. The crane should have adequate quantity of the following to meet the capacity lifting requirements: cables, devices, falls, sheaves, and pulleys. Other miscellaneous hosting equipment. Block cables should be clean, free of dirt and sand, properly lubricated at all times. Cables, ropes, and are kept free of kinks and stored coil. and are stored coiled. Crane operator have being in any lift of the operation, inspecting the cables of the wire ropes broken in the fractures and flattened and pinch spots and sheaves and drums that are checked on the proper on placement. Special safety considerations. 926 statistically a free moving crane potentially dangerous instrument in 1/3 of the injuries and sustained crane accidents resulting in the fracture, severed and severed limbs. Many of those injured in a crane operation, the crane accidents are preventable because they are too large to measure the result of the action conditions. The situation directly under the control of the operating crew. The crane work may be coordinated activity of the team and skilled workers. The operator, wreck master, riggers, and other assume the control lifter movements and similar actions. It is important the individual control responsibility clearly defined and procedure for transferring them thoroughly understood. The signals. 927. The wreck master, someone designated in his responsible for the given signals. The responsibility given the emergency stop signal belongs to anyone who is considered such a signal necessary. Copies authorized and signals should be posted in obvious places such as wrecking train. Personnel may become familiar with the crane directed. Operators must wait for the clear signal and designated signal man before operating the equipment. If there is no doubt of the confusion regarding the signal given to the operator, we must stop the operation, classify the signal making another move. And the figure 9.1 shows the standard high hand signals used in the operating the crane to direct, and the signals using the visibility and using lights and lanterns to give in the signal during the period of darkness. Alright, a tap on the hat is to use the main hoist. A tap on the fist, tap fist on head. That means that you're using regular signals for the use of the main hoist. The boom to an arm extended the fingers clutch. Pointing upward is the raise the boom. Lower the boom, arm extending the fingers closed down, but the pointing downward. Lower the boom. Swinging and extending point with the finger a direction and the swing of the boom is to swing the boom. The stop is any extending it palm down and holding position arm extended palm down holding position rigidly. Emergency stop, an extended palm down, move hand rapidly tight, right and left. They use a whip line, auxiliary hoist, tap elbow on the hand, but then use the regular signals. Hoist, with the forearm vertical forefinger pointing over the hand, small horizontal circles. Lower, when the arm extended to downward, forward finger pointing down, movement handled in the signals horizontal circles. Raise in the boom of the lower and the load, with the arm extended with the thumb pointing out the next fingers in and out of the extended hand movements as desired. Lower the boom, raise the load. When the arm extended with the thumb pointing down and the flex fingers in the out of the load as the load movement is desired. Move slowly. Use one hand of the given in the motion signal and place the other hand of the motionless in the front of the hand of the given in the motion signal. Hoist slowly shows example. Travel an extended forward arm handed travel. An extended forearm handed open, slightly raised, pushing motion in the direction of the travel. Travel one track. Will it lock the track and on the side of the indicated by the raise first and travel the opposite tracks in the direction of the circular motion. Other rotated vertically in the front of the body for crawler cranes only. Travel both tracks. We use the both fists in the front of the body, making a circle motion, each of the other indicating direction of the travel forward and backward for the crew crawler cranes only. Dog everything. Dog everything. Clasp hands in front of the body. This is standard crane directed hand signals. Overhead power lines. Wreck lines operations under the near electric power lines extremely hazardous. The closed electrical circuit different the voltage are required of the passage of electrical current. When a crane boom or cable of the comes in contact with the live power line, the crane cable of the booms and the load and the becomes electrically charged. A person on the ground steadying on the sway, loading and touching any part of the crane becomes a part of the closed electrical circuit and can be instantly electrocuted to the critical burn. The crane operator is responsible for keeping the crane boom and cables away from the power lines. Relatively safe while the cab shall be held. While the cab should he step off the crane and have one of the front of the crane step on the ground, he is also electrocuted and burned. Movement into wrecking crews, wreck cranes are powered by the independent movement of the gear-driven wheels. When the crane moves in the tow work and the wreck train, operators must follow the precautions to avoid the damage to the crane train or wayside objects. 3.3 bulletins. Secure the rotating deck parallel center line of the track, fastening the deck at the front of the rear ends of the bars, provided lower the boom in the traveling position, preferably pointing in the rear. Place the transmission lever in the neutral position. Disengage the driving gears so wheels are shown freely. Use the hand crate to draw the gears assembly out of the mesh. 7 safety load precautions. 9:30. Cables and tackles must not be overloaded when making heavy lifts of the crane of the derrick. Operators must be sure of the following: boom is properly positioned. Boom is highly as possible. Hoist cables have been greater capacity than the load is to be lifted. Hoist cables have no kinks or broken wires. Crane and level outriggers are in place. Brakes are given. A good working order load is to be lifted with a properly slung rigged. Load is kept near the ground and traveling not lifted higher than necessary. The swing is started slowly with the swinging loads. The loads are not left hanging in the hook. Safety factors. The safety factor of the ratio strength of the rope of the working with the load. For example, wire rope strength of 10,000 pounds. The total working load of 2,000 pounds would be operating with a safe factor of 5. This is not possible safety exact. If not possible to set the exact safety factor for the crane with the various types of wire rope. As for the factor of the safety vary the conditions. The proper safety factor does not depend only on the loads applied, but the following: speed, operation type, the fittings of the securing rope ends, length of the cable, acceleration, deceleration, number, the size, loading, occasion, and the sheaves and drum. The safety factor given in Table 9.1 has been established by the experience minimum required for the average operation. For the labor safety factors is desired in the greater safety, more efficient operation, safety working loads with a sling in Figure 9.2. Table 9.1 safety factor. The guys are with the minimum safety factor of 3.5, miscellaneous hosting equipment at 5, and derricks 6, and slings 8. Here's the chain slings. It shows the different single and a double with different chain sizes from 3/8 of an inch, graduating to 1.5 inch. How and what degree the double was pointed at from 5, 10, 15, 20, 30, 45, 50, 60, as in the arc of the chain slings. Shows the different poundage weight is from anywhere from a single 2,700 pounds on a single to 40,800 pounds on a 1.5 inch single. From 5 degree 470 to 60 degree is 70,000 pounds. The wire rope swings when two-ended brittle sling, a slip noose, or a 3-ended brittle swing with the axles at 45, with the angles at 45, 60, and 75. And slip noose is in between 3/8 of an inch and 1.5 inch size of the rope. Note: loads are based on slings good condition. Take up the slack. Start up the load slowly. Keep the slings in the twist and not from freeing twists and knots and kinks. Lift the center of the hooks never from the point. Distribute the load evenly on all legs of the sling. Inspect slings regularly. Do not overload. Safely working loads with the sling. Load formula. Safety working load selected by the mathematically determined in the tables. However, the following formulas are the rule of thumb methods of determining the safe working loads in tons for hooks, chains, and ropes, and cables, diameters, and inches. Hooks. When a hook starts to the arc, the square of the diameter of the chain, the 8 times the square of the diameter on the side of the length. The rope, the square of the diameter of the cables of the wire diameter, or a cable wire rope, 8 times the square of the diameter. Safety rules: crane operator must be sure of the following: only authorized personnel with the crane cab only enter the cross crane cab. No one in or about the crane must be started before the started. No one is in or about the crane before it is started. No hoist may be made while anyone is riding in the load. A warning signal is sounded by the traveling moving the crane when the load is approached near other than personnel. Hoisting and lifting material standard. Wire rope cable is used with wreck cranes with hoisting manila and silsila because it is easy to handle to carry with the hand of the tag lines and lashing rigging. L square put rope with both fiber and wire when keeping the coiled and when not in use. The size of the rope used in the U.S. Army designated as in inches in diameters. Fiber rope is twisted vegetative fibers together with a rope consistent with three elements of the fibers, yarns, and strands. The direction of the twist of the element is reversed and prevents the elements unraveling underload strain. The fiber rope is nearly the kind of the vegetable fibers in which they compose the manila rope and be made of the fibers of plant and leaves. The sisal rope may be made from the fibers of aloe leaves. Are too commonly used in the military service. Manila rope is superior to the other ropes, elastically strengthened wear qualities, and smooth runs well over the blocks and sheaves. 936 the minimum. 936. The minimum break strength of the manila and sisal rope is much greater than the safe working capacity. The difference between the two and the safety factors, the safety work capability of in tons of the given the manila rope approximately equal to the square of the diameter in inches using the safety factor of the 4. Under no circumstances should the fiber rope be loaded to load more than twice its rated safety working capacity. As ropes deteriorate, the faith load is one half the value is shown in table 9.2. 9.2 is the properties of manila and sisal rope. The nominal diameters in inches from 1/4 to 3 inches, and circumference inches 3/4 to 9 inches. Breaking strength in tons is 0.27 to 32 tons. Safe load tons of the FS 0.4 0.0 to 78 tons at 3 inches. Breaking strength 0.22 tons to 25.60 tons is a sisal rope and sisal rope. Safe load tons at FS 0.06 and 640. Wire rope. Wire rope is made of steel and iron wires twisted and formed strands. The strands may be wound around each other and twisted over the central core of the fiber of the steel rope. The direction of the twist of each of the element of the rope is known as the lay of the element. The regular lay of the accepted standards of the wired ropes that denotes the ropes in which the wires are twisted in the direction that are to form the strands. The strands are twisted over the opposite direction to form the rope. The regular lay rope, so the wire is almost parallel with the longitude axis of the rope due to the difference of the direction of the strand of the rope of the the rope lays are less likely to kink and untwist on ropes unconstructed with other lays. They are easily handled over well-loaded wire cable breaks the strain of time to prevent the corrosion of the internal abrasion boom wire rope should be lubricated with the lubricants thin enough to penetrate the inner strands. 938. Fiber cords. The standard construction of wire rope must be not as strong as the rope with wire cords. The fiber core and strands supplies internal lubrication, contributes to the flexibility reliance of the rope. The wire core ropes of the less suitable fiber rope core ropes. The operation shocks loads frequently. Rope construction is designated by the number of strands of the rope, number of the wires in each strand. Therefore, the rope composed of 6 strands to 19 wires each is 6 by times 19 rope. That's 6 strands by 19 wires each is a 6 by 19 rope. Therefore, the standard hosting capabilities of the more universally used of the other ropes construction. 939. Chains are composed of a number of the metal links connected together. The links are made of the round and oval pieces of routed wire welded to ends of a solid ring. After joining the connection of the link, the chain size is determined by the diameter of the rod composing of the links. While the chain lengths are stretched under the excessive loads, individual links will be bended only and slightly, and the chains the bent links will be made by suddenly fail of underloaded brakes. Since chains are resistant to abrasion, they are also used in lifting heavy objects to sharp edges that might cut wire rope. Blocks. 940. A block is a shell or a frame which holds the one or more groove pulleys called the sheaves. The sheaves revolve on the center pin axle. The swivel hook is attached to one end of each of the block. Often the eye is attached to the other. Type of blocks. A block is size determined by the length of the shell of the frame in inches the number of the sheaves they contain. Single, double, triple, and quadruple blocks contain 1, 2, 3, and 4 sheaves respectively. Blocks are identified by the construction manner in which they are used. The 2 types of blocks are conventional and snatch. Conventional block is constructed by the fiber and wire rope that must be reveaved and threaded with the sheaves, the type of the block found in the crane booms. The snatch block is the type of the block, also gated block, constructed with one side of the open permanent of the cable of the rope and the place in the sheath without reeving the block. When these is easily identified with a hinge and lock on the one side, with one on the hinge and lock on one side. This is normally used in the making of the riggings, obtaining the mechanical advantage with the cables of the rope. The continuous lines cannot be threaded in the sheath. Classification: 942 blocks are classified according to the manner they are used. Two types of blocks are fixed and running blocks. A fixed block is the block of the fastened with a stationary object that does not affect the mechanical advantage. Sometimes the leading block it does not permit the change of the direction of the cable. Running block, the block of is also called the traveling block, is fastened to the object removed by the lifted, and the block does not produce the mechanical advantage. In the cable, 943. The largest size cable and rope that must be used on a block is determined by the diameter of the sheath, the depth of the groove, and the size of the opening which the line passes over the sheath. The proper size of the line or just on one possible to visit the sheath, the clearance between the frame and the sheath, the diameter usually on 1/8 of the 1/9 of the sheath length, and the use of the multiple sheath blocks increases the weight of it can be lifted. Mechanical advantages increase. It depends on the number of the size of the sheath of the blocks, number of the parts of the cable between the blocks. Hooks. Railway cranes are equipped with two standard slip hooks, one large, one small. The large hook is rigged triple blocked on the main boom hoist. On the steam cranes, the small single in the hook is rigged on the single hoist of the line on the sheath at the end of the boom. The Army-owned diesel and mechanical cranes are maybe equipped with a double hook on the single hoist line. The slip hooks are made in the inside curve of the hook. It is an arc designed to be used with a which wire and the fiber rope and chains. Hooks usually are failed with the straightened, thereby releasing the load, and any deviation within a perfect linear arc indicates overloading. Safe workloads and drop forged steel hooks, various sizes, as shown in figure table 9.3. Table 9.3 shows the safe loads of hooks. The diameter beginning in the arc inches at 1.5 inch, and 2.25 and 3 inches. In following the same metrics down, inside diameter inches of the 1 inch is 1.25 inch. Length of the hook inches is 6 to 7 and an eighth of an inch, and safety on load on a hook in the pounds 3,400 pounds. 1.5 inch beginning of the arc of the inches on a safe hook, and the diameter of the eye is 1.75. Length of the hook is actually 10 to 11.32 of an inch. A safe load on the pounds is 8,000 pounds. 2.25 on the beginning of the arc is inside diameter inches of 2.75, with the length of the hook of being 14 to 13/16 of an inch, and the safe load of the high hook pounds of 13,600 pounds, and 3 inches of the diameter beginning of the arc inside of the diameter of the inches is 3.5, with the length of the hooks in inches 19 and 3.25, and a safe load of 24,000 pounds. Crane rigging. Wrecking crane and rigging includes a combination of cable, rope, and tactical used to raise to move the handle of heavy loads. Rigging may use the chain of the direction pull to take advantage of favorable terrain. Each with various combinations of cable blocks and pulleys must be rigged and created with mechanical triple advantage to deploy the crane rigidly affecting the crane. Wrecking crew personnel must understand the various parts of how and effort and the resistance are distributed among them. When the effort is exerted to one at the end of the cable of the rope, where there is equal resistance applied at the other end. The tactical must be used in the resistance objective to move to exceed the effort of the available if the difference is supplied with the mechanical advantage of the rigging. 946. The heavy load main of the hoist raised is lower in the big block of the crane boom. The main hoist consists of a number of the wire rope cables running through the load of the block upon the peak of the boom, through the sheaves down through the main hoist drum to the crane cab. The number and size of the cables vary from lifting the capacity of the crane. The auxiliary hoist of the brace lowers the hook at the edge of the end of the boom. Cable to the line of the run of the sheaves of the light load hook of the sheaves of the tip of the boom. The auxiliary hoist of the drum. The cables vary lifting the capacity of the light load hook. Equipment recovery and line clearing operations. 947. The number of the cars, locomotives off the track, whether the upright overturned or on the right of the down embankment or on the ravine or riverbed. Although the factors of the equipment recovery and line clearing operations damage equipment that is unavailable to move is set aside of the later recovery. The contents may also be considered flammable, explosive ladings presenting in certain safety hazards, maintenance of the way signal, maintenance of personnel, restore tracks and communication facilities that have been damaged, affecting after traffic black logs have been made. The wreckage equipment that can be picked up, evacuated the shop, salvage, and wreck train operating the track pattern. The division superintendent and other senior officers must consider the following factors to performing the equipment, the recovery, and the clearing of the operations: the military situation, size and scope of the wreck, density of the traffic, availability of the personnel, wrecking cranes available. Rerailers. 948. Rear railers are cast iron devices and simple derailments to retract the locomotive. Cars and locomotives. The railway are carried on locomotive of the wreck train. The railers are made with the fit over the rail and grooved to the runway. They're designed to guide the wheel flanges on the rail on the proper running position. Some railers are designed for use of either wheel. Other design are used in the pairs of rail with the pairs. Those designed for the use of either wheel must be spiked and cross-tied in the free, preventing the slipping. The rail shown in the figure 9.3 is used in pairs. Using pairs. One of the prepared railers guided the wheels on the outside of the rail on the right side over the rail in the top position. The other on the left side guides the wheel on the onside of the rail to the flange position. All derailed cars are pulled onto the truck and impossible, and the coupling is too large or too far away from the secure the connections. Chains should be used. The re-railing device is shown in the tapper opening the fit of against the outside of the web of the rail. A wedge is driven between the outside web of the re-rail device. The wedge tightens against the rail and prevents the re-railer from slipping as a result of the thrust of the car wheel. This is in the figure 9.3 shows using a re-railer to retract a re-railed car. Note that never attempt to re-rail a diesel locomotive under its own power. Serious damage may result in traction motors or spinning wheels. Unloaded traction motors attain dangerously high speeds. Okay, other equipment 949 mobile cranes and bulldozers may often be used effectively clearing operations when the derailment of the wreck occurs in areas accessible from the road and complicated derailments involving the large number of the cars. Mobile cranes and bulldozers may be used in the move of the car, the bodies, car trucks within the reach of the wrecking crane. The mobile cranes can also be used in lift and loads and small items during the clearing and salvage operations. Specially designed hydraulic jacks may be available to lift and re-rail the rolling stock. They are especially useful in minor obstructions must be cleared and quickly. Preliminary procedures is not practically to list all specific instruction covering the different kinds of lifts that must be made under the wrecking conditions. Each wreck is different, depends on the following before any recommendations can be applied to the particular wreck. Situation, weather, timing, and lifting hazards, damage to equipment, and number of the capacity of the wrecking cars available. Wrecking cranes available. The wreck master and other officials on the site consider all factors, decided that the action taken. Preparation for a lift. The total weight of the anticipated lift should be calculated accurately as possible, including the weight of the material, objective the handle, the blocking, slinging, other devices between the hooking and loading, light weight of the railway car stenciled on the side of the car, net weights of the content of the load of the car available for the train, and the documents calculated total weight of the checked against the official test of the capacity of the wrecking crane. Crane operators must never operate the weight handling equipment in excess of the rated capacity without specific authorization of an officer in charge of the operation. Load security. The load should not be lifted or moved unless there has been a hitch into the switch in such a way that no shifting or weight of the slippage load of the loss or load will occur. Incorrect breaking can damage the lifting gear and by breaking the fiber of the wire or the cable, then resulting on the making subsequent lift of the increasingly hazardous operation. 953. Brake test. Heavy loads should be lifted and then a few inches off the ground. Load brakes and tested to be sure that they will be holding load of the raised as any higher. The capacity lifting capacity should always be checked in determining the previous load of the crane that has been idled in a long time. The hoist of the load blocking it at the boom several times. Brakes lightly applied with the hoisting of the heavy load. They will be dry only at moisture of the braking line. Excessive moisture of the braking line will cause the brake performance could cause the load to drop. Footings. Let me back out of this. Here you see in Figure 9.4 the outrigs with your latch and basically your outrigge and the use of wood blockings. The footing. Make sure a safety line, depending on the large having of the form of the foundation level of the base of the crane of the steel rails of the track usually provided the foundation of level base of the maximum use of the outriggers of the blocking. The outriggers are usually making heavy lifts when making the lift near the crane maximum capacity at any radius. The blocking of the rest of the firm of the base. Small clearance must be applied with all points of the A. Figure 9.4 level base is required to avoid the swinging of the loading and reducing the possibility of the tipping of the level swing. The repair requires a minimum power of the fastest stability. Outriggers securely extending the block of the H attending near the capacity of its left footing and must be level and solid. Outriggers are not extending the crane of the manufacturer recommendation limits. Here's the figure 9.4 shows a lot at point A and the blockings and the latching of the outrigging. The lifting, loading, mechanical advantage. In order to lift beyond the strength of the capacity of the person lifting, the mechanical advantage to be determined. The mechanical advantage is determined in multiplying the force exerted by the force applied to the lifting and the move of the load. Mechanical advantage may be commuted by a simple and compound tactical system. Here's a simple, this is a mechanical advantage of the various tactical riggings, number 1 through 5, with we'll explain the W and P part to it, following 2, 3, 5, 2, 3, 2, 3, 5, 10, 16 pound pulling line. A simple tactical system that has one cable of the rope, one or more cable blocks. The system, there are two lines leaving the load on the fixed end and the fall line. The pulling line, the fall line, the bearing of the pulley, the force of the block of the load is called P. The force on the block of the load is called P. The tension of the rope in which it blocks is P. The two forces each will see P in lifting of the block. The total force being applied to the block is 2P for two forces on each of the pulling of the block on the load. The mechanical advantage is 2. The simple the tactical system of 3 lines leaving the block of the mechanical advantage of the 3 simple tactical 2 double blocks and 5 line figure 9.5 and number 3 and 5 lines figure leaving the load on mechanical advantage number 3. You actually see the number 1 line with the 2 line and 3 line with the 3 number 3 with the weight in the pull of the load, and this one has 5. So compound tactical system. A compound tactical system has more than one of the rope, the 2 with more blocks. The compound system made of the 2 more simple systems. The fall line of the one simple system is fastened to the hook of the traveling block of another system. Simply and may include one or more block in such a compound system for exerted on the fall line. The fall line of the simple system is multiplied, and the mechanical advantage of the system applied with the fall line and the second simple, the first force of this multiple in the mechanical advantage of the second simple system. The compound system is 5 lines leaving the load of figure 9.5 number 4. The fall line of the tactical attached to the traveling block of the 2 lines supporting the mechanical advantage. 2 times 5, 10, and more complicated. The system is figure 9.5 with number 5. The system is made up of 2 simple systems. Each of the 4 line supplies supporting the load. The travel blocking the first simple system is fastened to the fall line of the second simple system. The mechanical advantage of the compound system is 4 or 16. The dead man. A dead man provides the anchor of the additional pulling power of the secured in an adamant object. The dead man can consist of railing, steel beam, or other buried objects as deeply as grounded as the force exerted requires. The dead man has a guide of the connected in the certain when digging is not practicable to hold fast to the pickets, the cables, the girders, the ground anchors, and so forth as much as the anchor of the tactical hookups. An example of these field expeditions are shown in figure 9.6. Figure 9.6 and figure 9.11. The holding power of a dead man, ordinary earth, the depth of the anchor is from 3 to 7 feet, with a vertical inclination of the pole of the vertical horizontal self-resistant to Medman's area of the pounds per square foot. A vertical it rises at 3 feet and to 7 foot at 32,000 feet, with 1 to 2 to 1 to 4. Hi, Paula. Okay, back to the thing, guys. The holding power of the dead man in ordinary earth. And here shows a log dead man where they had buried a log with vertical timbers to anchor the track sling. So That's using natural earth. Here's a steel beam dead man with a steel beam behind vertical timbers, a sling anchor, and a degree. The steel dead man. A combination of steel picket, hold fast. All right, here's a rail with a different I-beam steel picket in a picket line across the bar with dead man poles in the center at the end. This is a picket hold fast, which is has the pockets tied together, or the stakes tied together. Yeah, picket hold fast 3-2-1 combination, and use two or three trees for natural anchorage. All right, guys. The dead man installation. Let's zoom in here. All right, 959. The hole in which the dead man is buried to show the deep enough to provide a good bearing of the solid earth. The bank of the direction of the guy line should be an undercut, and at the angle of 15 degrees, the vertical tim shall be driven in the ground against the bank of the same the angle to provide a solid bearing surface in the inclined trench of the cable way should be cut and through the bank of the center of the dead man. The short beam and the length of the bit can be placed under the guide, the line of the outline of the inclined trench. The guide line may be fastened securely to the center of the dead man, so that the standing of the part of the line which the pole incurs leads to the bottom of the dead man. The bed method of the fastening of the guide line plus an angle of the bank of the reduces the tendency of the dead man to move upward and on either the whole. The strength of the dead man applies partly on the strength of the length of the beam but mainly on the holding of the power of the earth. Picket hold fast installation. The strength of the picket hold fast depends on the following: how it is driven into the ground, the diameter of the kind of the stake used, the holding of the power of the ground, the depth of which the stake is driven, the angle of the stake, the angle of the guide on the line of into the ground. A combination of steel picket hold fast provide more strength than the wood of the rope. Combination of multiple picket of the holds the form of the stronger hold fast as if it does not single picket hold fast. To make the multiple hold fast, two or more pickets are driven in the ground in desired combination and lashed together. The principal part of the strength for the multiple picket hold fast strength of the first to the front of the picket to increase the surface area of the first picket against the ground. The three pickets are driven under the ground close to each of the other and lashed together. The lash of the second picket of the group is the lash in the third pocket of the figure 9 and 10 of the intervention pickets are provided with the additional strength of two trees used in the natural anchorage of the shown in figure 911. Lift 961. When repetitive lifting is required, position crane as short as possible with swinging the cable cycle in order to reducing the cycle time. The multiple lifts of the projected over the assigned area. The position of the crane is beginning the work of the as the direction traveled to different areas. Lift completed in one area. The moving of the crane in the next area. The positions 962. Extra formulas or specific rules. Position wreck cranes cannot be prescribed. Many of the factors determine the crane working position. The most undesirable position for the lifting, which is the boom at the right angle of the crane of the body. The position often required is declaring derailed the wreck cranes of the locomotives on one side or the other of the track. The outriggers are usually required lifting the capacity of the loads of the position. For the heavy lifts, the crane should be positioned whether it has maximum lift capability or capacity or the number of the loads of the lift is the position of the crane, so forth that the loads may be lifted in most of the remote point force, which in the position of the crane has been greater boom clearance and subsequent crane of operation are not blocked. 963. Each new job location condition is checked by the adequate boom clearance during the repetitive lifts. When the conditions of may remain unchanged, one of the clearance of the check, the carefully continue the observation, eliminating the needs of the raising, lowering the boom on each cycle. When wrecking cranes in position for safety reasons so low and they're not lifted over the personnel equipment, they are also positioned so that they do not overtouch the overhead of the obstruction, especially electrical wire crane hooks are highly effective as they will clear personnel and vehicles. Radius clearances are established in position of the crane to provide adequate space between the load and the being handled and the point of the final placement. The loads are hoisted in high enough to ensure proper clearance and no higher than the necessary. All right. 964. Resistance. When overturned the car, the locomotive is derailed. The resistance may be overcome by the force supplied by the crane rigging. In the serious wrecks of the cars, the locomotives are often thrown into some distance of the track. They are much damaged to the back of the lifting position, which may involve several forms of the resistance. The form of the resistance are described below. Friction. Friction is created by the contained with the objective being pulled across the ground. For the example, the amount of friction resistance offers the soft sand and less gravel. Grade resistance determines the weight of the object being pulled down. On hill and the angle of the slope. But the rule of thumb, the grade resistance determined by the multiplying 1/16 of the weight of the car, the locomotive, is the number of the degrees of the slope. And an example, the resisting encountered with the pull overturn of the car up on the embankment of the track of the level. Over resistance, the part of the weight of the objective subject as the diesel locomotive, which against the force of extracted on the upright back of on the track, and the half of the weight of its object, the maximum, and with the beyond the center of the gravity of the point of the lift. So oftenly, the weight is resisting recovery when any of the overturned car, the locomotive, is set upright. The resistance is computed it was one half of the weight over the object is to be set up. The tackle resistance, the loss of energy force that is created by the flexing of the cable of the rope, of the cable stuffing in the groove of the pulley of the sheave turning on the pin, and so forth. This is loss of tackle resistance must be overcome before the load can be moved. Each pulley sheave of the tackle creates a resistance approximately equal to 10% of each of the resistance created by the gravity, terrain, and so forth. It's for the standard 40-foot flat car to be re-railed, picked up with creates a resistance of 60,000 pounds, or 3 sheaves that are used in the tackle assemble or on the crane boom. The tactical resistance of 18,000 pounds, or 30% of the 60,000 pounds. Total resistance. The total resistance that must overcome before the object can be moved. The total resistance varies. The condition varies. For example, the car body weighing 20,000 pounds or dragged up to the 60-degree and ice-covered slope would generate the total resistance of 28,000 pounds. The same object pulled over and would create a total resistance of 5,000 pounds. An object dragged through the motor's mirrors could create a resistance equal to its own weight. Operating techniques. Precise rules techniques cannot be given because of the diversity wide range jobs on the which wrecking crane may be used. The experience and the judgment of the wrecking master crane and the operator will dictate the procedures followed. Cables, 966. Cable breakage can cause serious injuries, loss of life, preventive property damage, and wire rope proper manufacturer recommendation. Serious factor of 6 of the lifting operators at full engine power. The safety factor of the crane hoisting the most. Free moving cranes usually drop at about 2. Do not load hoisting lines into the point which the engine begins to stall, or use engine power as a gauge for safe line lifting capacity. If the engine is stalled and by line pulling only, flywheels inherently add to the rated power. The monetary increase in the lines of the pulled 2 to 1.5 the times the full engine power line pull will cause the cable to snap. Fast lowering and sudden stops will also be overloaded in hoist lines, booms, hoist lines, and usually encounter the heaviest loads when the load is just leaving the ground at the point at the angle of lifting the flat that considerable in error to the starting and stopping. Alright, working radius, 967. The general rule of the working radius is the load should be handled in the shortest possible radius, keeping with the job condition of the boom lay, the height of the lift, the boom of the clearance at all points of the swinging cycle. The boom, given the boom length, the steeper the working angle, the shorter the working radius. Near the boom of the leaves, the vertical position, the greater the loss of the radius, and each of the degree of the cable increase the boom angle. Load should be not hoisted higher than necessary, should be lower than be as quickable as possible for the proper height of the swinging and travel spotting. Boom hoisting control, lifting the load of the up and down the boom length of the cycle, increasing the wear of the tear on the equipment. Hoisting is generally in the best method of the following the principal factors of the control, handling, and loads: speed, smoothness of operation, stability, shock, and tipping in the feel of the load, and safety. Using the boom of the careful operator will slightly lift the load to check and ensure the insecure before lifting completely off the ground. If not satisfied, he should lower the load, investigating the correction of the condition, speeding and the element almost fully with the control of the operator due to the central physical force. The crane swing should be slow enough to avoid outward throw of the load. The action of the crane hook at the end of the line is similar to the pendulum. Therefore, the hook can be controlled by the slow speeds of the tag lines required with controlling outward swinging of the free moving cranes. The condition permitting the headline to easily loading down and guided the engine place. The hoist line is eased off the unit until the crane settles between the general and the stable position in the cane. Instead of the boom, the crane can be rooked and released. The load of the operator should inspect the cables of the boom, the drums, to ensure that they are in place. The cables may have become wedged or damaged or broken. The block position before the hoisting the load, upper block of the position directly under the load is to permit the vertical lifting to prevent prevent the load from swinging and kicking out. The taglines are used to increase the stability of the blocks of the load to close the sheaves at any time. If the blocks close together with the hoisting, continues, the hoist line may break. Therefore, adequate clearance between the block and the point of the sheaves where they're lowering the boom, if not the hoist line tightening and breaking the wedge of the down or through the other cables as a safety factor is the least of the two fall wraps, and cables should be on the drums whenever they're in operation. The car lifts 970. When lifting a car, the coupler is the quickest and most practical place to make a hitch. However, the couplers must be properly blocked and prevented damage to the car body. Some cars have jack pads, lifting eyes are integral into the frames. Cars do not equipped with the features can be easily hoisted passing the car slings in the underframe. The car trucks 971. Most car frames, braces, and the trucks may be chained to the car frame lifted from the car body. When the car body must be lifted from the trucks, from the clearance, the brake rods must be disconnected, manually cut into two with an accelerating torch, and trucks must be lifted intact separately in one or several ways. Quick emergency lifting can be made in insertion chains of the cable slings through the side of the frame openings. 972. When lifting cars, re-railing cables may be placed under the body of the solid top of the car underneath the trucks using the slinging. That arrangement of the sling with the adjustable spreader bar gives more stability, lifts, and arrangement of the also preferable coupler hitch to prevent the crushing of the body of the cars and gondolas. It must be practiced on the brace at the top. But bracing it may also be required at the solid top of the car. Ours is cross-tied at the top of the proper length of may also be used the brace. Most of the modern passenger cars have holes throughout the heavily braced collision posts at the ends of the pole. At each ends of the holes permit the use of the hooks and slings in lifting. The use of slings of the coupler lift method of blocking of the cars are shown in Figure 912. Because of the weight of the construction of the ambulance unit, cars and couplers lifted are not used in jacking pads, and lifted lugs are used in lifting cars. Here is a picture of a method of lifting passenger cars. You see, here is a coupler attachment hooked to the coupler with a blocking indicating blow switch. Reduce the probability of damage to the coupler during crumpling of the body. Back to the faceplate of the end sill on the coupler attachment. The other one is a collision post attachment on the top of the and the sling gives a safety guard to the heavy and most part of the show. The collision post attachment ends at the ends. The post attachments at the ends and AD and locomotive lifts. Due to the weight of the re-railing the diesel electric locomotive, the steam locomotive requires a heavier and more careful rigging than the used for the cars. Small locomotives may be lifted with one erect crane using a spread bar rig. The larger, heavier locomotives may require use of 2 or 3 cranes depending on the type of the truck. Locomotives involve removing the truck of the diesel locomotive may be decreased by lifting required by up to 40 to 50 tons, which is necessary to roll or lift off the locomotive some distance of the track beyond reach of the crane of the rope. Extensions should be fastened in suitable connectors. They should be the same size and quality as the crane car. 974. The two principles of the diesel electric locomotives: Army-owned fleet, the four-rack of the recovery plan, the weight of the typical diesel electric steam locomotives in the Army fleet are shown in Chapter 8. Lifting and rolling. 975. Train crews at one each of the ends should be rolled, and two cranes at one each end should be used to roll a locomotive. Although the single crane large enough to handle an actual load sling provided at any attempt to lift the boom both ends at the same time, that could result in buckling, framing, the coupling of the crumpling of the body structure. Blocking. 976. The body structure of the locomotive, the heaviest directly over the bolster load of the rolling operation, can be carried out best in these points. Actually, adequately blocking is necessary to distribute the load. All mounting the blocking necessary depends on the amount of the roll required of the locomotive is on, and on the side of the crane and pulling the considerable angle of the entire locomotive must be blocked and reduce damage. The major pull in which the part of the structure during the initial rolling operation locomotive approach is the upper right position of the crane, and lifting them becomes the vertical side of the blocking becomes more important. Here shows a method of rolling a diesel electric locomotive with a single crane. Say your block is over the roof. O cable attachment. The outside the use necessary. Method of rolling a diesel locomotive train: double slings, bubble blockings on both sides, slinging the arrangement with a bar and pulling the locomotive embarkment out of the embarkment. Rolling 977. Two slings are used in each end of the locomotive operation. Each sling is passed from hook to down on the side and around the center places, back into the up the side, and then back to the crane hook. The stress caused by the rolling the locomotive falls under the side of the sling at each of the figure 913 view. When view 3, when the roll is complete, the load held is in the 4 slings attached to the 2 cranes. The 2 slings at each end of the crane, the load of the next now secure either the lifting or the dragging. The method of using the method of using attaching 2 cranes onto a locomotive slinging position when upright in the minimum hook. The hook to the rail 24 feet are necessary as the rear rail of the locomotive is shown in figure 914. When possible, 24 feet of the sling should be preventing the crane hook from the bearing of the top of the locomotive. The locomotive is lying on its side, using the sling as reducing crushing on the top of the sides. Locomotive, after running and its completed actual lifting has begun. When the lifting is range of the wrecking rain, boom, other conditions does not permit a 24-foot clearance, shorter cable rigs must be used. Here's another picture of the double method crane pulling out the train out of the embarkment. Other precautions: attaching extension cables from the underside of the sling to prevent the crane from hooking bearing on the top of the rolling locomotive. The extension removed from the rolling is complete before the lifting starts. The load spreader, the lifting the locomotive is in position in figure 914 view 2. The crushed load of the top sides of the locomotive is approximately equal to the load lifted. The side of the blocking is not sufficient to protect the locomotive structure. Therefore, the suitable load of the spreader is placed on the top of the locomotive at each end of the support of the load. The load spreader can be made suitable wooden beams such as cross-diable proper lengths and notch at each end of the hole of the slings is a sleepage. Electromotive division, diesel electric locomotive 979. Electric diesel locomotive frame designs are supported by the bolster. The frames can be straightened down and bent if they span from the lifting point to the grader. The true weather, the lifting of the slings attached with the lifting lugs, couplers, and jacking pads. Any commercial type EMD locomotive can be lifted at extreme end of the coupler hitch. If the other end of the support of the bolster, military railway switcher type of locomotive should be lifted on the lugs only by the lugs. Special lifting bars. The lugs are designed only to vertically lifting, should not be used in slide to slide the locomotive. 980. When only one of the diesel electric locomotives has been lifted, placing the blocking between the truck and the frame of the opposite ends, preventing the cracking center plates between the truck and the bolster. The trucks are designed so that the end of the locomotive can be dropped below the rail, the height, without the damaging of the liners of the truck remaining on the rail. Any simple derailments, if the derailment end is lifted extremely high, the liners are susceptible to damage the clearance, provided they enough to take the care of the normal defections during the derailing, mostly observed with deflection track and springs, and the wreck crane masters must not only at one of the end of the locomotive more than 6 inches above the rail, unless the other end of the lift is enough to separate the center plates of the truck bolster. Lifting lugs 981. All EMD railroad switches equipped with the slip lifter lugs on each side of the frame. The lugs are designed to permit the rope slings to directly attach to the bolster. When the re-railing of the type of the locomotive should have a minimum hook to the clearance of the 70 feet. Under the normal conditions, the 2 slings and lifting bars are used on either end of the locomotive in emergency and on end of the switch. One up to 125,000 tons may be lifted at the coupler. This is a method of an EMD railroad switcher. Lifted the lugs outside on the rail. Using the following procedure, simple derailment. Using the following procedure for the simple derailment involving one of the truck when the locomotive is upright. Re-railing the locomotive using re-railers if available when practical. Use spread bar and 2 wire rope slings to adequately strengthen available. 2 slings and locomotive is equipped with lifting legs. No lifting beam is necessary. If using a sling and coupler hitch of the locomotive is equipped with the standard coupler locomotive, the locomotive is not equipped with lifting lugs. If the lifting cannot be made on one side or the other, the wreck crane cannot reach the bolster. The coupler must be blocked as shown in the figure 915. If avoided with it, never use the coupler hitch and any locomotive equipped with a retractable coupler. Truck removal 980. 983 EMD locomotive frames are strongly enough to permit lifting operations of the truck attached at least at one end is supported by the bolster. However, the truck removals may be required under certain wreck conditions. The EMD freight switcher locomotives in the Army fleets with with use of two 4 wheels and two 6-wheel pedestal type trucks. The preliminary steps that use to remove the locomotive disconnection brakes, the sand hose, and airline traction motor leads. Depending on the locomotive type, the 4 wheels are disconnected, removing the 5 holding bolts, and removing these bolts free the truck locks the body bolster and the side bearings. For the free 3-wheel trucks, such as those on the EMD military railway switcher MRS1, removing the 2 nuts of the bolts securing each of the bearing clipping, removing the clips. The locomotive frames must be raised in the minimum of 6 inches on the sideway removal of 27 inches on the end of the ways removal. American Locomotive General Electrical Diesel Electrical Locomotive. The frames of an American Locomotive General Electric diesel locomotives are the Alco GE General Electric locomotives. American Locomotive General Electric diesel locomotives. Even though the specially braced are designed to lift at the bolster, lifters closer to the passenger locomotives may cause excessive stress on the trucks and attached at the time of the lift. Road switchers on the trucks attached can normally be lifted to designated lifting points. Lifting eyes are designated only on the vertical lifts necessary to drag and roll the locomotive. Slings should be attached at the center of the truck. This shows a jack pad lifting lugs for an American locomotive of the GE series. Truck center plates, 985. When lifting one of the end of the Alco GE locomotive, the same precautions taken as when lifting an EMD locomotive. Refer to the figure paragraph 980 and how to lift the EMD locomotive. The lifting lugs, Alco road switchers equipped with a combination of jacking pads, lifting lugs attached with the frame of the body bolster. Methods of attaching cable slings and lifting as shown as no other hitches available. The coupler kit hitch could be used as an emergency lift for all classes of Alco GE or American Locomotive General Electric locomotive. Simple derailment. The recommendation to lift when one on the both of the derailed locomotives is upright close to the rail, as shown in Figure 916. The slings, rather than re-railing, are used in the Alco GE locomotives. The gear case rigging of the driving axles carry the using of the re-railing. Do not use the coupler lifting because of the dragger springing the coupler. And more important, seriously springing the frame of the buckling of the cab. Another disadvantage of the coupler is extremely care to prevent the damage of the center plates on the end of the truck and is not being lifted. When the coupler lift must be used, the truck on the lifted it should be disconnected. The coupler should be locked and sling placed close to the body as possible. Caution: under no circumstances should a coupler lift be attempted on both ends at the same time. Not only the frame will be sprung, but it would also be very likely that the locomotive will roll over. Chuck removal, 988. With exemptions certain to the extreme lifts of the frames of the American Locomotive GE series road locomotive switches strong enough to permit the re-railing without the removing of the trucks. The truck removal may not be necessary under the certain conditions because the limited crane capacity or to lighten the weight of the lift. The American Locomotive General Electric locomotive in the Army fleet include the 4-wheel, 6-wheel trucks. In either case, the traction motor leads, airline, sand brakes, brake rods, any truck safety chains may be disconnected. The 4-wheel trucks are disconnected with the locomotive frame, removing the 4 bolts that are used to hold the truck locomotives. Removing those bolts always lock to disengage the side bearings of the American locomotive. Passenger locomotives not in the Army fleet are equipped with 6-wheel trucks. The trucks locking on 6-wheel trucks are held in place by a bolt which passes through the lock and engages 3 locking lugs on the body bolster. Removing the 2 bolts allows the lock lugs to swing free. The all American Locomotive GE MRS type 1600 horsepower multiple gauge road switcher 6-wheel truck does not have to have these locks. Disconnecting the service appliances safety hooks frees the truck from the frame. Inspect the diesel electric locomotive of the cars with the rail lower the locomotive car body on the truck, performing the following inspection of the locomotive on the car and the truck. Raise the journal boxes, turn the wedge of the brass in place, ensure the truck of the springs are aligned, examine the journal lubrication of the packaging, and any need for oil and any close of the box. Inspects the brake rigging bolster for loose and dragging parts. 990. The preliminary report of the work and derailment given to the dispatcher includes the estimate of how much the track is torn up in the rail lengths, extent of the damage. The dispatcher relays information maintenance to the superintendent for his plans of maintenance of the way. Superintendent is also a section foreman in the required numbers to assemble their crew, the tools, the equipment, the wreck site of this prescribed the rendezvous point, whether they can be transported by the wreck of the train, ballast of the rails, ties, and so forth. They are usually available. The emergency roadside stockpile, supplemental limited quantity track of the repair materials carried on the wreck train. The 991, the Transportation Railway Engineering Company maintenance of the way section crews, and they begin to remove the debris spilled of the car, dragging cross-ties rails of the wreck cranes, and clear of the damaged equipment. Ballast is racked and levied and replaced as necessary as from the roadbed. No time the new rails are laid and connected to the gauge and spikes to expedite the start of the traffic spiking. The terminal is limited to each of the other tie plate, the other two bolts that hastily tighten pace and angle bars. Moving the train over such hastily repaired sections is controlled by slower orders issued by the dispatcher. Surfacing the line is limited to initial minimum standards required for the same moving types trains of low speed. Completely ballasting, bolting, and lining, spiking, and surfacing can be done in congestion by having been cleared of the wrecked equipment and removed and line open. Restored communications. 992. Derailed cars can break off and knock down telephone or telegraph poles. This can be the division of wire company communications. It is not necessary during the recovery of operations to cut these lines and remove the poles to permit the wreck crane booms necessary to clearance. In such cases, personnel of the communication of the railway signal maintenance platoon, transportation railway engineering company, the repair of the circuits as soon as possible to enable division dispatcher to communicate with the stations. Derailments occur with the interlocking plant territory and railway signal maintenance sections. Personnel make necessary repairs for interlocking systems. Chapter 10, Railway Planning.